Hello, dear students. Welcome back to my YouTube channel. Yeah, hello, Sana beta. Hello. Hello, dear students. Welcome back to my YouTube channel. Yeah, hello, Sana. Okay, one second. So, as you know that in the previous class we had a discussion on many things, right? We got to know how to derive the work done by the external force, by the electric force, or electrical potential energy relation. Okay, these things we done in the last class. Now, in today's class, what we will be discussing now, we will be discussing about uh, potential difference in a linear charge wire density infinite. Okay, and then we will discuss about the graphs, slope. Then we will be having the discussion of the electric dipole, electric field, axial point, equatorial point, general point, electrical potential, axial point, equatorial point. Then we have general point. Then electrical dipole in a uniform external electric field, the torque one. How it performs SHM, how to find the frequency, how to find the time period. Okay, these things, if time permits, we will complete the whole these bunch of things in today's class. So I guess these are the previous class things. Okay. Now let us start today's class, and today class is one of the most important class. Okay, and also today we had the second last class. This is how much I hope and I wish it should be a second last class. Second last class of electrostatic. Okay, so let us just discuss these things then without wasting our time. And if you find any glitch or if you find any sort of issue with my video, you can just let me know in the comment box. Okay. Okay, let's start today. Let's start today's topic. Today's topic name is electric potential difference. Electric potential difference due to infinite line charge. Infinite line charge. Okay. So as you can see on the screen now, I have written the thing. It is electrical potential difference due to infinite line charge. So as we all know that infinite line charge means we had some sort of line like this. It is from infinite to infinite with some charge density plus lambda. Done? Okay. So if this is point number A and the distance between A point and the wire is R1. This is point number B. Distance of point B and the wire is R2. Wire is R2. We know that if this is positive line, so my electric field will be outwards. This is my net electric field, no? Net electric field. Look, we know that for this line charge, we have the formula K lambda by R sine theta 1 plus sine theta 2 for perpendicular, and for the parallel it is K lambda by R cos theta 2 minus cos theta 1. But if we have a infinite line, theta 1, theta 2 both are equals to 90. When we place the values, we only have one value, 2k lambda by R. So my electric field is how much? 2k lambda by r. Done. Point number A, point number B. Look now. Look now. Okay. Okay. What will be the potential difference? What will be the potential difference between A and B? I guess I will write, sir, potential difference dV is equals to minus integrate E dot dr. I will integrate potential I have to find when I am going from A point to B point. A point it is R1, B point it is R2. This expression you need to write. What is the integration of dV? Sir, integration of dV would be AV only. Then and you need to Rigal Betaji, I guess you have your command is something different, na? Okay, so my upper limit would be VB and lower limit is VA. Okay, minus is minus. Limit R1 to R2. What is E? E is 2k lambda by R, then dr. Then dr. Look, so I will write now here, right? I will write now the whole scenario here. So upper limit, that means VB minus lower limit is VA equals to, look, minus is outside, 2 is constant, K is constant, lambda is constant. So I need to integrate from R1 to R2, 1 by R dr. Okay. Do you know what is the integration of 1 by R? Yes, sir, it is ln of R. I will write VB minus VA. Nothing. Don't write anything now. Okay, it is VB minus VA minus 2k lambda. Then 1 by R, I can write ln of R. Upper limit is R1, lower limit is R2, R1. So I will write VB minus VA equals to minus 2k lambda. Upper limit is ln of R2 minus ln of R. This is my answer. But you can see here now, from here you can see what? Sir, when we are doing VB minus VA, my answer is a negative. Do you know why? Look beta. As we know that if we are going in the direction of electric field, my potential will decrease. That means, sir, potential at A will be more than potential at B. Okay. So my A potential is more. Okay. So you want to study the physical chemistry from my after completion of my physics? No, I will just teach you the physics chemistry. Okay, don't worry. Okay. So we know that potential at A is more than potential of B. Okay. And if we are doing VB minus VA, so it will come to the negative, no? So I will change the whole near right to. I will just take the minus common. I will write VA minus VB equals to minus 2k lambda ln of R2 divided by R1. Minus cancel out. So VA minus VB is equals to 2k lambda ln of R2 by R1. This would be my expression for it. Easy. And important thing that you need to remember, important thing. No? Look, important thing. Important thing is here that only potential difference is defined for line. Defined for line. Okay. If you want to write potential, if you want to write potential from previous classes, we are noticing that, sir, if we want to define potential, so we will take one point as an infinite. So I will take B point infinite. So what I can write here now? I will write, sir, if I need to define potential, so I will write, sir, R2 tends to infinite. So what I will write? I will write VB, no? VA, no? VA. So what is VA now? Sir, VA minus VB. So VA is V only, VB is 0. At infinite, 2K lambda. Ln of R2 is infinite by R1. So ln of infinite is not defined. It is not defined. Therefore, you can write potential for line is also not defined. That's why we are using potential difference in line. We are using potential difference for line, not the potential one. I guess this is a bit of the weird thing, no? But you need to remember these things. Very easy. Okay, very easy things. Okay, look now. Uh, okay, one thing that we had the discussion on, that is yesterday, and it was like, sir, my electric field is equals to, it is nothing but minus dv by dr. If we are going in the direction of electric field, my potential will decrease. It is minus dv by dr. Okay, and what is dv by dr? I will write here, sir, E is E, minus is minus, dv by dr is slope of VR curve. It is slope of VR curve or VR graph. Remember this one. Remember this one. What is the meaning of E equals to minus dv by dr? It is E minus slope of VR curve. Oh, sorry, VR graph. VR graph. Sir, how to now manipulate these questions? Let us suppose we will take a simple question. Okay. Let us take a simple question. And the question is like, this one is V and it will be in volt. Suppose this one is X and it is in meters. My graph is like this much. This is my graph. 0, 1, 3, 5, 10. This one represents my graph. We have to calculate electric field at x equals to 4. You need to calculate electric field at x equals to 4. Sir, how we can do it? Graph is given to us. We need to find electric field. Okay. Look, we have to find electric field at point 4. At point 4, now that means between 3 and 4 is 4. This one. Okay. Look here. You can see from 3 to 5, my slope is constant. My slope is constant. That means the value at x equals to 4 or the between 3 and 5 is same. So what is this theta? Look, this theta is more than 90 degrees. If your theta is more than 90 degrees, so my slope came out to be negative. This thing is from basic mathematics of 11th. If my theta is more than 90 degree, my slope is negative. So my equation came out to be, sir, it is minus slope. It is minus slope. Okay. And what is slope? So slope is tan theta. What is tan theta? P by B. So it is E, minus is minus, slope is negative, and what is it? It is P by B. Minus minus plus, so I will write positive P. What is P? Perpendicular is 10. What is base? Base is, look, it is this much, no? This much. So 5 minus 3 is 2. 2 ones are 2, 2 fives are 10. So E came out to be 5 Newton per coulomb. Easy or super easy? Easy or super easy? Easy now? Okay. Now one more numerical. Look, that's why now you need to remember each and everything from 11th first chapter. Why? Look here, you can just find how to find the slope. In back in 11th class, we need to give 2 to 3 hours to understand only the slope, right? That's why you need to keep your eye open every time. Okay, next numerical. Next numerical on the graphs, right? It will looks like this now. X in meters, V in volts this side. So we have a graph. This one is my graph. Okay, 40, 30, 10, 2, 6, 12, 16. I have to find out at x equals to 15. X equals to 15. So as we know that, look, this point is 6. This one is 12. 6, sorry, 16. 2, 3, 10. I guess 15 lies between this 12 and this 16. Look, theta is more than 90. If theta is more than 90, so you will write, sir, slope will be negative. It will be minus p by b. Okay, so what is E? E came out to be negative slope. Negative slope. So E, negative slope is how much? Slope is minus p by b. It will be positive p by b. What is p? What is perpendicular? Look, this much now. It is 30 minus 10, it is 20. What is base? 16 minus 12 is 4. 4 ones are 4, 4 5 are 20. So my answer is 5 Newton per coulomb. Okay. So you need to manipulate your answers like this, no? Super easy. Super easy. Okay, let us do some miscellaneous numericals. Okay, let us do some more numericals. So you will have a very vast varieties of numericals, right? Do one numerical. And numerical is like, let us combine all the topics from our previous classes. So we had a numerical. And numerical is like concentric spheres. My concentric spheres. Okay, look now. Look now. Yes, if the radius of small one is smaller, radius of bigger one is capital. These white lines represent the radius only. Okay, now look. Charge on the inner sphere is Q1, outer sphere is Q2. This one is point number A. This one is point number B. So we have to write the potential and VA at VB. So what we need to find? VA minus VB. To get VA minus VB, I need to firstly find VA. Okay, VA. What is VA? Look, VA. Okay, VA. Look, you can see here, no? You can see here, look, this one. Look, this point, this A point, it is at the surface for smaller one, but it is inner side for B. Okay, so I can write surface. It is at surface for A plus it will be at inner side for B. Surface for A, which formula I can use? KQ by R. It is K Q1 by R. Inner is same, it will be K Q2 by R. This is VA. Done? Okay, you can continue with DC Pandey. NEET version of DC Pandey. You will find a varieties of numericals. No? DC Pandey is good. Now, let us do a VB now. VB. 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 VB is outer side. It is outer for A plus it is surface for B. So I will write K Q1 by R plus K Q2 by R. So now put these values here now. So VA is how much? It is K Q1 by R plus K Q2 by R minus VB. It will be K Q1 by R minus K Q2 by R. These two get cancelled out. So I can write VA minus VB. I will write it as KQ1 by R minus KQ1 by R. I need to write like this. Okay. So one numerical came from this particular topic and it was asked in IIT. That is, if charge on the outer surface changes to minus 3Q, what will be the effect on VA minus VB? This numerical was asked in IIT and it states that we have the same scenario where we need to calculate VA minus VB. Now, second statement is, if we now change the Q2 by minus 3Q, is there any effect on VA minus VB? Yes or no? I need an answer from your end. Is there any effect on VA minus VB? Any effect, beta? Look, I guess you're not in the mood to give me the answer, right? So I will give you the answer. Look here. As we can see in this particular equation, the Q2 term is not included. Yes, there won't be any effect. Great, beta. Queen, great. Okay. So as the statement or the equation here gives the idea that there is no dependency of Q2 now. If no dependency of Q2, so you will write no effect. No effect. Easy now? Easy or super easy? Okay, now next numerical. Next numerical. Suppose we had a sphere. One sphere, one more sphere. Okay, Suprita, हाँ बेटा. We have two spheres, na concentric spheres. Radius of smaller one is r. Radius of bigger one is capital R. Charge smaller one is q1. Charge capital one is q2. What will happen now? After some time, now after some time, what happens here? Look now. We are using earthening techniques. So I will just earthen the inner radius now. The inner sphere, I will just earthen it. Okay. So what will happen? Look, the outer charge will behave outer as it is. Radius is same q, sorry, r and r. So let us suppose the inner charge is x. Okay. After earthening, na, charge distribution will take place. We are connecting two bodies, and we know that the earth we assume at the zero potential body. Now we are connecting the inner surface with the earth. What will happen? Charge distribution will take place. So let us suppose after earthening, the inner charge of the sphere is x. So what will be the value of this x? There is no issue. Let us suppose, take this point as a point number P. The point P. As you can see, we have touched it with the ground. That means the potential at P will be equal to 0. Why? Because we have just added or connected the point P with the ground. Ground potential is 0, so that the potential of P is also 0. Okay, sir. Now, as per the formula that we used to use in the previous questions, no? So what is the potential of the point P by the inner surface? Sir, it would be K Q. What is Q? Q is X by R. Plus, I will write K Q2 by R. It is VP. So for the formula, we know this one. From the concept, we know this one. We can just merge these two things. Can I write Kx by R plus KQ2 by R is equal to 0? K cancel out. I will write X by R equals to minus Q2 by R. So X came out to be minus R by R into Q2. So the inner charge will be minus R by R Q2. Easy? Easy or super easy? One second. Okay. Look now. Let's discuss one numerical from AIPMT and IIT. One good numerical. And the numerical will be like, look it, one good numerical. We have a three concentric spheres. 1, 2, 3. We had three concentric spheres. Okay. Now, first one, radius is A. Second one, radius is B. Third one, radius is C. Done. Point number A, point B, point C. Charge density is plus lambda, minus lambda, plus lambda. If potential at A is equal to potential at C, potential at A equals to potential at C, then find relation between A, B, C. Find a relation between A, B, C. Okay. Do you know what is sigma here? Sorry, rho here. It is surface charge density. Surface charge density. And it will be equals to charge by area. Charge by area. So what is first one? I will talk about the first one. Okay, first one. So what is charge? Q1, it is plus sigma into area. Area is 4 pi r square. What is r? R is a square. First one. Q2 equals to minus sigma 4 pi b square. What is Q3? Q3 is plus sigma 4 pi c square. Okay, that Q1 we know, Q2 we know, Q3 we know. Now we have to find out VA. Firstly, what is VA? Look, for VA, VA potential, I will write K Q1 whole divided by A plus K Q2 by B plus K Q3 by C. Okay. So what is VC? It is VC now. VC K Q1 by C, K Q2 by C, K Q3 by C. As per the question, V and VC are both equal. So I will write K Q1 by A plus K Q2 by B plus K Q3 by C equals to K Q1 by C plus K Q2 by C plus K Q3 by C. You can see here from this equation, K cancel out. What is Q1? Q1 is sigma 4 pi A square divided by A. Q2 is minus. Now I will write here minus. It is minus sigma 4 pi B square by B. Q3 is sigma 4 pi C square by C equals to Q1 is sigma 4 pi A square by C minus sigma 4 pi B square by C plus sigma 4 pi C square by C. Look, from this equation, sigma cancel out. Look here. 1a cancel out, 1b cancel out, 1c cancel out. Okay. C, 1c cancel out. Okay. 4 pi cancel out. So my answer is A minus B plus C equals to A square by C plus B square by C plus C. C cancel out. So I will write A minus B equals to A square plus B square by C. Okay. Look now. So this one I will write, it is A minus B equal to A square plus B square is A plus B, A minus B whole divided by C. Cancel out. So a particular line is my answer. Easy? Easy or tough? Easy or super easy? Very easy. Now let us start uh, topic known as electric dipole. Okay, important topic. What we have a electric dipole. Electric dipole. Dipole means two poles, two polarity. So electric dipole is a arrangement of two equal charges but opposite in nature placed at some distance apart. Then this configuration is known as electric dipole. By definition, if we have two charges minus q plus q separated by a distance, and for easy calculation we are taking the distance as 2 times a or 2 times l. Okay, it's a dipole. One more thing is dipole moment. One more is dipole moment. Dipole moment is the multiplication of either charge. It is multiplication of either charge into distance between them. Here I will write, sir, dipole moment, and it is a vector quantity. It is a dipole moment is a vector quantity. Okay, it is a vector quantity. It goes from negative charge to positive charge. It goes from negative charge to positive charge. If we talk about it is units, it is coulomb meter. It is coulomb meter. And if we talk about it is magnitude, we denote it by letter P. It is magnitude is Q into distance, that is 2a. These things you need to fit into your mind. Electric dipole, what is electric dipole? It is a configuration of two equal but opposite charges separated by a small distance 2a or something like that, right? It is, and one more thing, we have a dipole moment denoted by letter P, from negative charge to positive charge. Vector quantity, unit coulomb meter. Coulomb meter. This was all about the electric dipole and dipole moment. Now let us place this dipole. Let us place now this dipole in external uniform electric field. Then we will see what will happen to it. Okay. If we have a field, if these lines, if these lines, if these lines represent field, if these lines represent field, look, okay, as we know that it is a uniform field. Why? Because the gap between the lines is same and the direction of the line is towards the same point, it is rightwards. Okay, so what is it? It is uniform electric field, E. Now in between I will place a dipole. I will place a dipole. Okay, look, this is my dipole. Look, this is my dipole. This is my dipole. This particular point is minus q. This one is plus q. Okay, and the dipole moment will be from minus to positive. We know it. And the whole distance is how much? 2a. This is 2a. And look, and if let us suppose the angle of inclination is theta. Suppose this angle is theta. So this side would be 2a cos theta. And this side would be how much? So it would be 2a sin theta. Look, electric field is coming from positive terminal to negative. Now we assume it. If it is positive, so it will attract this terminal towards itself. It is minus QE then. Force. This one, it will get repelled. It will be minus QE minus two forces acting on a single body in opposite direction, but the line of action is different. So here what will happen? There will be a torque from rotational motion of 11th. We know if two equal and opposite forces are acting on a body and the line of action is different, so the body will experience a torque. It will experience a torque. So sir, what is torque then? So torque is equals to force and perpendicular distance. It is what? Force multiplied by perpendicular distance. Torque is tau. Force is how much? QE. And perpendicular distance is 2a sine theta. 2a sine theta. I will write it equals to Q2a e sine theta. We know from the above equation, dipole moment is how much? Q times 2a. So I will write torque is equals to Pe sine theta. Look better. P. Dipole moment is P. P is also what? Vector quantity is vector quantity. To vector added by the sine theta is a vector quantity. So I will write tau vector equals to P vector multiplied by E vector. This thing I need to note down. Torque experienced by dipole placed in uniform external electric field is P cross E. It is how much? P cross E. Done? Any issue? Beta? No issue. Look now. Look now. Look now. Look now. If now I need to rotate this dipole. Okay, look now. So my dipole is in this particular way now. This particular tip, the force is being exerted in this way. On this tip, force is being exerted this way. So automatically this will come across this way. Okay. And at the end, it will be here only. So suppose if I need to rotate it like this. Look, automatically electric force is in this way now. If I want to rotate it like this, so I need to apply some extra force. I need to some extra force. So look, how much amount of work done I need to apply to rotate it by angle theta. How much energy or how much work done I need to apply to rotate the dipole by small angle theta. Okay. So I will write here, sir. I will write here work done equals to force into displacement. But it is in how much? 2D. But if we are talking about the rotation, so I will write work done is nothing. It is torque into angular displacement. Now I want to rotate it from theta 1 to theta 2. Okay. So integrate from theta 1 to theta 2. What is torque? So torque is P sine theta. It is P sine theta, then d theta. Okay. So I will take, look now, P is constant. P is constant. I will write work done equals to P is constant, P constant, E constant. No? So I have to integrate only which one? Sine theta. I guess the integration of sine theta is nothing but minus cos theta. I will write here minus cos theta. Upper limit theta 2, lower limit theta 1. So I will write W equals to minus P cos theta 2 minus cos theta 1. Or work done equals to of external agent equals to P cos theta 1 minus cos theta 2. So this much of work I need to apply to rotate my torque, this electric dipole in a uniform electric field. Okay, look now. So I just rotate it like this, na, against the electrical force. So I applied some force. I done some work done. Now, if I take my hand from the particular dipole, the dipole will rotate now. Why? Because the energy gets stored as a potential energy. My work done gets stored as a potential energy of the dipole. Okay. So what I can write here, sir, my work done, or I will write here, work done by external force is equals to change in the potential energy. Okay. So I will write, sir, it is P cos theta 1 minus cos theta 2. It will be potential energy final minus potential energy initial. Final minus initial. You need to take some reference point. It is some reference point. You need to take it now according to NCERT. That is theta 1 is 90 degree. At this 90 degree, my energy would be equals to 0. Theta 2 is theta. Energy is U only. As per the reference given by the NCERT, so I need to write PE cos 90 degree minus cos theta equals to U minus 0. P cos 90 is 0 minus cos theta U. So, or I will write U came out to be minus PE cos theta. Or I can write that U came out to be minus P dot E. This is my expression. Easy? This one is my expression. Look now, look now. Here, if suppose now, look, if my theta is 0 degree, it could be 0 degree. If my theta is 90 degree, if my theta is 180 degree, if theta is 0, I guess U came out to be 0 minus P. If theta is 90, U came out to be 0. Theta 180, cos 180 is minus 1, so U came out to be plus P. So this is my minimum value. This is my minimum value. And this is my maximum value. Maximum. So at minimum value, I will be having a stable equilibrium. It is what? Stable equilibrium. At maximum, I will have an unstable equilibrium. Unstable equilibrium. Okay. Here, I don't need to define what is stable equilibrium and what is unstable equilibrium. Stable means if we are displacing any body and after some time it will come to its original position. Unstable means if we are rotating the body, it will not come to its original position. No? It is unstable. Done? Clear? Okay. This was all about the electric field. Now we have the next point known as how to find electrical field due to dipole. Okay. Now I will take you at some time. Then we have to complete the whole thing. No? So what I will write here? Electric field due to dipole. Due to dipole. Electric field due to dipole. So I have to make a dipole here. Minus Q plus Q. I will extend this part. So if we are going in the direction of the line which joins two parts, this line is known as axial line. This is what? Axial line. So I will take any point here. Let's go this point, point P. So look, if it is central point, look, this distance is A. This distance is A. Distance from the origin of dipole to my point P is how much? Let's go X. Suppose, look now, here I have small charge Q naught. Positive ripple, so electric field due to, if it is B and A, electric field due to B equals to K Q whole divided by X minus A square. And electric field due to B, it would be, sorry, due to A, it would be inverse. It will be K Q divided by X plus A square. Electric field are in the opposite direction. So if we need to calculate the net electric field, I will write big minus small. Which one is big? I guess EB is big now, close, minus EA. What is EB? It is KQ whole divided by X minus A square minus EA. E is how much? KQ X plus A square. Okay. So I will take KQ common. Then it is X plus A square minus X minus A square whole divided by X square minus A square whole square. So E net came out to be KQ A square plus B square minus 2 times plus 2 times AB minus A square plus B square minus 2 times AB whole divided by X square minus A square square. E net. Look here. Minus X square cancel out. A square cancel out. I will write KQ. 2, it is 4x times A whole divided by X square minus A square whole square. Okay. E net. I will write 2K Q2AX whole divided by X square minus A square square. Do you know why I write this one? Now look, Q2A, it is dipole moment P. So my whole equation becomes 2KPX whole divided by X square minus A square whole square. This much. If my X is more than A, so I will write X square minus A square is approximately equals to X square. So therefore, my E net is equals to 2KPX whole divided by X square square. It will be equals to 2KPX whole divided by X power 4. Cancel out. It is 2KP by X cube. So this relation is electric field at axial point on dipole. Okay, so this is how you have to find the electric field axial point of the dipole. Clear? Yes, 2 kb by x cube. No? Now next part. Next part is equatorial. Next one is equatorial. Equatorial. Look here. It's minus q plus q. Okay. Origin A and A. I will take up any point here, x distance apart. This part. Look now. This Q will attract it, electric field this one. This Q will repel it, electric field in this one. Okay, I will just add these things. So this side would be x square plus a square root. This would be x square plus a square root. So look here, theta angle, theta. E, so it would be, it is E positive, it is E negative. So I will write here E, so it will E positive cos theta, then E negative cos theta. One more component here, it will be E positive sin theta. Then this one, E negative sin theta. Okay. Look, what is E? E is K Q by R. R is R square plus X square A square. That means these two get cancelled out because equal and opposite. So what will be E net? Sir, E net will be equals to 2E cos theta. Why? Because 1E cos theta, 2E cos theta. That is 2E cos theta. 2. What is E? E is KQ by R. It is KQ by R. R is how much? X square plus A square root, then square, right? Square. Cos theta. B by H. B is how much? A by H, no? It will be X square plus A square root. So I will write E net. So E net is equals to 2 K Q A whole divided by X square plus A square. This cancel out. So we have 1 plus 1 by 2. It will be K Q 2A whole divided by X square plus A square, then 3 by 2. This is what? P. So my electric field net at the equatorial point came out to be Kp whole divided by x square plus a square 3 by 2. One more assumption, that is if x is more than a, so I will write x square plus a square approximately equals to a square. So E net is equals to Kp whole divided by x to power 3. Okay, so this is electric field at an equatorial point. Equatorial point. So as per the data that we discussed here now, so electric field due to axial point equals to 2 kp by xq, and electric field due to equatorial point is kp by xq. So therefore you can write E axial is equals to 2 times E equatorial. Just remember. Yes, beta. Look, I am just showing the derivation. Na? These are the whole derivation for your boards. Everything. Na? If I'm just teaching only for the NEET and JEE, na? So I should have just not shown the whole derivation. Na? Look, I'm showing the each and every one. So if you are preparing for boards, yes, I am giving each and everything to you. The definitions, notes for your boards, and the derivational part here. Everything I'm just providing here. Okay, so first of all, we are covering your NCRT, we are covering your board syllabus, we are covering your NEET, and we are covering your JEE mains. Each and everything we are covering here. You can do one thing now. After watching my all the lecture series, go open your book NCRT. Don't trust me now. Open your NCRT book. Then read each and every line of NCRT. Then you will find what kind of material I just showing to you in class. And after the class, just try to give the DPPs that you are getting from your college, you are getting from the college, or you are getting from the tuition, right? The coaching one. Okay. Now, basically, we got here the E. I got a lot of sleep right now. So E axial equals to 2 times E equatorial. Okay. Okay. So now the third point. Third point is we have to find out one general case. One general case is electric field at any point. Electric field at any point. At any point. Look now. At any point. What does this any point means? Suppose we had an electric dipole. Minus q plus q. Distance is 2a. We know it now? 2a. I will take any point here. This point P, any point here. A random point P. And this point P is, let us suppose, the central part. It is A and A. Making angle theta. It is R. It is R. What will happen now? What will happen now? So I guess one thing that we know now. One thing. So look now. This particular this one, this minus q. It will attract it. This q2. It will repel it like this. We know it. We know it now. No beta ji, no oscillation right now. Okay. Done. If this is P, so can I write this thing also? It is P cos theta. Is this one P cos theta? And this one is P sin theta. Now this point. Now look this point. This point beta. If we are talking about P cos theta, look here now. Now just rewrite the whole thing. Now we have two dipoles. One dipole with dipole moment P cos theta and the length is R. This point. I guess now this point is the axial point. This one is the axial point, no? This one is the axial point. One more, we have which one beta? P sin theta. Dipole moment is P sin theta. Okay. And for also this one, the point P is here. Now look, the point P is here. Here, I guess for P sin theta, it is at equatorial point. It is at equatorial point? Yes, sir. So for axial point, what is my value? E axial? Sir, E axial is 2kp by r cube. So here I need to change it. It is 2k is k. P is P cos theta. It is 2kp cos theta. And my distance is r is same. It is r cube. For this one, it is how much? It is kp by r cube. I will write kp. What is p? What is p? P is P sin theta divided by r cube. We have now two electric field. Both are perpendicular to one another. So I guess E net will be like this. E net. This is my E net. Yes, sir. Two vectors and what is E net? So I guess I will write E net is equals to under root of E1 square plus E2 square only. Why? Because these are on the 90-degree angle. Okay. What is E1? E1 is 2 to the 4. I can write 2 K P cos theta by R cube whole square plus E2. E2 is how much? Kp sin theta by R cube square then root. So we have the whole mathematical thing now. Physics is done here. E net. What I can do here, look, I will take K common, P common, R cube common. What we have here? It is 2 cos theta square plus sin theta square. I will write or root here, right? So I will take K common, P outside, R cube outside. In 2 to the 4, it is 4 cos square theta plus sin square theta. Kp by R cube. Look beta. 4 cos square theta, I will write it 3 cos square theta plus sin square theta. Look, cos square theta, sin square theta is 1. It is 1. So my E net is equals to Kp by R cube under root of 1 plus 3 cos square theta. This is electric field at any point. It is general point. It is what? At general point. Now, if you want axial, that is why if you want axial point. If you want axial, for axial, what is theta? Sir, theta is 0 degree. Place 0. So what is E net? Kp by r cube under root of 1 plus 3 cos square theta. It is cos 0. Cos square is 1. So it is Kp r cube 4. It is 2 Kp by r cube. If we talk about equatorial point, for equatorial, theta is 90 degree and cos 90 is 0. I guess E net is equals to Kp by r cube only. Very easy, no? Very easy. Yes, very easy. Okay. Now, one more numerical is here. That is, look beta. If we have to find out the angle theta or alpha angle, okay? If we have to find the angle alpha, do you know what is angle alpha? Yes, beta. Do you know what is angle alpha? Okay. Yes. Look here. If this is E1, this is E2. Okay. E net is something like this. It is E net. This will be angle alpha. What is this angle alpha? Look, I guess I will write tan alpha. P by B. What is P? E2 by E1. So look, important derivation. Okay. So I will write tan alpha equals to E2 by E1. What is E2 now? I guess we had the E2 now, no? E2 is Kp sine theta. Okay. E2 is Kp sine theta by R cube. And E1 is how much? It is 2 Kp cos theta by R cube. Cancel out Kp, Kp cancel out. So we have 1 by 2 sine theta by cos theta. So therefore, tan alpha came out to be 1 by 2 tan theta. One more expression to get these things done. Very easy. So we have 20 minutes. In 20 minutes, I will try to finish the whole electric dipole concept in these 20 minutes. Okay. So be in the class. So I guess we had concluded the electric field. Now we had the electric potential. What we have now? Electric potential concept for electric dipole only. Look now. We have potential concept. Potential concept for what? Electric dipole only. So if we have a dipole, minus q plus q, this length is a, this length is a. Some distance apart, I will take a point q, point p. This distance is x. First case, axial point. So here we will be having two potentials. Potential due to minus q charge. It will be k, q. Q by distance is how much? A plus x. V plus q, it will be how much? K plus q divided by a minus x. What is V net? Sir, V net is how much? Minus kq divided by a plus x plus kq divided by a minus x. I will do a little bit of mathematical manipulation. It is kq 1 divided by a minus x minus 1 divided by a plus x. So here, what is V net? Sir, V net came out to be kq a plus x minus a plus x whole divided by a square minus x square. A cancel out. So V net came out to be, it is 2kqx whole divided by a square minus x square. Okay. Assumption, if x is more than a, so x square minus a square. Is it a minus x square or x square minus a? 1 second, beta ji. I need to figure it out now. A square minus x square, a plus x. So I will write here. It is no, it would be x minus a. Now this is wrong here. Be x minus a. It is x minus a. Okay, it's x minus a. X minus a. So here what we have. 1 second. Whole thing I need to write. So I guess it will be a plus x minus x plus a divided by x square minus a square. Yes. So it is 2kq a x square minus a square. It will be x square only. So v net is equals to 2kqa whole divided by x square only. Okay. Look, this much is equals to electrical potential. This much. So I can write it equals to 2, not 2. It is k only, no? I will write kp divided by x square only. Kp by x square. So electrical potential. Look, electrical field is different. It is 2 kp by 2 kp r cube. But electrical potential is kp by x square only. Okay. Now part B. Part B is for equatorial position. For equatorial. Look here. Minus q plus q. A x. It is x, right? Potential, if this is that is for y. Suppose simplicity. Potential due to minus q will be kq. Kq divided by y. Potential due to this one. This one will be it's y only now. Potential due to plus q. K plus q due to y. So what is V net now? Minus kq by y plus kq by y. Cancel out 0. So electrical potential at the equatorial point is 0, but not at the axial point. Done, beta? Okay. Now third case is at any point. Third case is at any point. At any point. Look now. Minus q plus q. A. Any point. I will take any point here. It is point P at the angle theta. If it is P, so how much this one would be? P cos theta. And this much would be P sin theta. Done? Okay. So what is V net? What is V net? Look, for P cos theta, the point P is at axial point. For P sin theta, the point P will be at equatorial point. And we know that equatorial point V is 0. For axial point, what is V? Sir, it is kq divided by distance, it is r, it will be r square. So I will write, but look, it is kp, sorry, it is kp, na? But here p is not p, it is p cos theta. So I will write k net is kp cos theta by r square. If I need to change it into the vectors, I can do one more thing, na? Look, I will write r cap here. I will just make a vector, not a vector, na, something like that. I will write kp cos theta. So I will write here kp cos theta divided by r square, that will be r vector divided by r. I will write kp dot r whole divided by r cube. This one is not important, but just to make sure to how to do the manipulation properly. Okay. Done? Easy? Easier, very easy. Easier, very easy. So we have last 15 minutes to class. We will complete the whole thing now. Last 15 minutes class. Look now, we have now potential energy concept. Okay. Potential energy. What do you have now? Potential energy concept. Let's look now. If we have here one dipole moment, here we have two dipole moment. Electric field is E. It is an axial point. It will be 2 kp by distance related for r cube. Okay. So what is potential energy here? Here, na potential energy. So potential energy U is equals to minus Pe cos theta. We know that U equals to minus Pe cos theta. Here, P, which P is present? Sir, P2. Electric field is how much? E. So it is due to E1, na? It will be E due to 1 cos theta. U minus P2. What is electric field? So 2K P1 whole divided by R cube. Angle is 0. I will write cos 0 degree. I will write U came out to be minus 2K P1 P2 divided by R cube. This one is super easy, na? Super easy. Within 30 seconds, I just concluded. So how to find potential energy at any particular point P? Look, here we have charges now. We have charges minus Q. Here we have plus Q. Due to these charges, we have the electric field here, right? This electric field due to first one. I have to write it. And electric field due to one potential is P1. Potential is P1 here. I need to write the dipole moment. Okay, one more thing. Sir, what will be the dipole on P2? Na? Torque. So torque on dipole. Torque on dipole. Which dipole? P2. Torque equals to P2 E1 sin theta. So I guess the angle is 0 degree. Look, P2 is like this, E is like this, na? Theta is 0, so tau is 0. So no torque on the dipole P2. And the force, how to find the force now? Na? Force. I guess force is minus du by dr. Minus d by dr. What is U? I guess U is minus 2k P1 P2 divided by R cube. I will write F equals to minus minus plus. It is plus 2k P1 P2 P1 2k P1, that we have P2 P2, then we have differentiation of R minus 3. So F came out to be 2k P1 P2. It will be minus 3 R minus 3 plus minus 1. Okay. So F came out to be minus 6k P1 P2 whole divided by R to power 4. Easy or very easy? Easy or very easy? Huh? Very easy? These are not important now. That's why I'm just going fast. But I am giving the full information to the class. Okay. One last topic. Last topic. And last topic will be like that. How to find the frequency or all these things. No? Look. If we have a electric field. This is my electric field. And my dipole is like this pending. Minus QE plus QE. I displace it somehow. Now look, it is like this. I displace it and I just take my force out. Now what will happen now? This force will try to take it in this way. This force will try to take it in this way. Now look, it will come down like this. Now go like this, coming back. Now it will just do this thing. Now it will just rotate like this, right? Rotational motion. It will do some rotational motion like this. Okay. So if moment of inertia, if moment of inertia is I given, if dipole moment is P given to us, and if we slightly displace it, find frequency of the rotational moving. Find frequency. Sir, how to do it now? Look, torque is how much? Minus Pe sin theta. Slightly displacement means theta is very small. If theta is small, so sine theta will becomes theta only. So tau came out to be minus p theta. Okay, tau is I alpha. I alpha is minus p theta. So I guess my alpha came out to be minus pe by a into theta. And my angular acceleration is minus omega square into theta. Compare it. So omega square is equal to pe by I. P means dipole moment is electric field. So what is, so omega came out to be under root of P E divided by E. What is omega is 2 pi by T, or I can write 2 pi F equals to under root of P E divided by I. So I will write my frequency came out to be 1 divided by 2 pi under root of dipole moment electric field by moment of inertia. So this is my expression. Done, beta? Okay. Only one topic now not covered, that is equipotential surface. Equipotential surface. We just complete whole chapter without one topic, that is equipotential surface. So tomorrow most probably we will end the whole chapter electrostatic, in which we have discussed electric charge, electric field, electric potential. Only one topic left, that is equipotential surfaces. Only one class left. Okay, I guess tomorrow we will discuss this thing and chapter complete. Easy, beta. Easy. Okay. And tomorrow I will take class. Then I need to go somewhere now, so we will have a break for a couple of days. So in those couple of days, try to just complete your whole backlogs in these chapters, right? So we had, I guess, 16 classes. So try to complete these 16 classes before the starting of the new chapter, so that you will have a very good grip on the whole concept. So next topic we will take electric current, then we will take capacitance. Okay, because in capacitance, the series parallel combination, all these things, no, you had to get a very good idea from the resistors, because we had done the resistors back in 10th class. So from that thing we will take an idea, we will take a lot of numericals. Then the same approach we have to apply in the capacitors. Okay, so first of all we just complete this topic, then we have the electric current, then capacitor, then magnetism. Okay, so in first chapter you all know that everything is new to you now. You are not having a very in-depth knowledge about the terms, right, and the equation. Now in second chapter you will find 40% already known all these quantities, no? Then we have to work only on 60%. Then in third chapter you have already know the 70%, you need to work on 30% only. Okay, it is not like that first chapter is not related to the second one, not to the third one. It is not like that, right? First to complete the whole one, then you will find second one is very easy. I guess for today's class, we had discussed more than enough. Rest thing we will discuss in tomorrow's class. Until then, bye, take care. Good night. Bye beta. Good night. Good night. Bye beta. Bye.